Hello, my name is Sami Alwash. I'm from team 60 of the assignment 2 of the class Cloud and Cluster and Cloud Computing from the University of Melbourne. And today I'm going to walk through some part of our code for this assignment, basically the Ansible notebook and the tweet and the tweet harvester script that we have created for this assignment. So the playbook, the Ansible playbook. So the playbook is this YAML file. It will be run by this bash command line. So first we need to read the SAMI OpenRCSH. So this is specific to me. Each group member has his own OpenRCSH file on their local machine. Because this was generated by the MRC by my on my account on the MRC, and when running this, I will need to input my own password for the MRC. So this allows the machine to connect to the MRC via my account, and then we just launch the playbook with this host file, which contains every IP address of our nodes, of the nodes that we use in the MRC. So first, the playbook, the first task would be for this computer to generate the nodes. So we can see here from the localhost that it will be this computer that will be acting. So different variables that it will use are here in host vars nectar.yaml. So we have every instance name and the name of the volumes they will use. Talking about the volumes, here they are. So we have their name and the volume size we want to use. We also define every security group that we want to use, up to 5, I think, on the MRC. We are allowed only to 5 security groups. And then some common variables that will be used through the task. So just for you to note that this specific task, it is basically taken from the workshop, one of the workshop of this class. So first we need to use this role, which is OpenStack common, which will verify if Python and pip and OpenStack SDK are installed in the local host. If they are not, it will install them. Then OpenStack volume will create the volumes that we have stated in the host var. Same thing with OpenStack security group. It generates the security group and the security group rules that we want for this project for every node. And then OpenStack instance will generate the instances and connect them. Generate the instances, send a message if the creation was successful or not, and with the IP addresses, and just ping them to see if they are available. Once the instances are created, we put their IP addresses in this host file that I mentioned earlier. And so once this is done, we don't need to run it anymore. It will just skip. It will not technically skip the steps, but just say, okay, this is already existing for everything we want to set up. Then comes these 2 different tasks to set up the CouchDB database. So first, why 2 tasks? Because we want a cluster database that has, we can see it in the host, that has 1 master node and 2 slave nodes. So we need first to have a setup for the same setup for the 3 nodes, and then we need to specifically tell the slave nodes that they are dependent on the master node via a different task. So first the variables for this task. So the variables are a specific volume path for Docker. There are some instructions or some useful variables to connect to the MRC, and some variables for the CouchDB database. So, setting up an admin and with a password and a cookie. I think it's common. Yeah. So common will have the same function as the OpenStack command, but this time for every node. And it will not just check if Python and pip are installed, but if every dependency that we need are installed. Then it is Docker. So this task is taken from the workshop and is just setting up Docker on every node. Volumes. Okay, volumes has a default YAML playbook which contains some variables for this task specifically, and it will install some dependencies and mount some dependencies and create some directory and mount the volumes to these specific directories. And finally, set up the Couch database. So same thing here. We have some variables that are only for this task. And yeah, and here we have the code which creates a Docker container for the a Docker container that is which the task would be to run the CouchDB service. So it will use an already created image in the cloud, in the Docker cloud. It will load this image to run the container, and we set up in the end some variables, a user with a password and a secret password. The CouchDB database, the CouchDB database will have its own 3 different ports. So the first one to connect to it, the second one to have some this port is just is there for communication between every nodes. And yeah, I think that this comment is not updated. And these ports 9100 to 9200 are for logs. So once this is done, we use this task for every node on in the Couch that are used in the CouchDB for the CouchDB service, except from the master node, so slave 1 and slave 2, and we'll run CouchDB slave nodes setup. So still these variables, and here because for the moment the 3 nodes have their own container having their own CouchDB service, And now we're saying to the slave nodes that their CouchDB service are in fact slave services connected to the master node, to the CouchDB service in the master node. So that's what we do here. So this is the point of this whole task. And then the CouchDB database is set up. So one important thing, whereas this one, the generation of the instances can be run several times, it's just that the other times will be useless because everything already exists. Here for the CouchDB database, if we run several times this script, it will actually delete the preceding database and create a new one. Well, sorry about that, and create a new one on top of it. Not on top of it, just replacing it. So we had an unfortunate event during our coding during this project, because I happened to have deleted this database while we have when we already had harvested some tweets for more than 1 week. So this was pretty unfortunate, and this is why we instead, well, we used the historical tweets that were available for us, that Richard gave to everybody. So yeah, this is, we don't want to run these several times, only once. And now about the Twitter harvester. So it has its own node, which is slave 1, I think. So yeah, slave 1 will take these variables, so to connect to the MRC. Yeah, and it will use setup Twitter harvester this role. So the thing is, here we want to use a specific script, which is tweet harvester.py. So we first need to clone this script into the node. So that's why we use a quick git clone. We just clone our repository, our git repository on the node. Then we verify if Docker is well installed, and we create a Docker image a Docker image that will refer to this script using this Docker file. So the Docker file creates a harvest working directory and copies everything here in everything in tweet harvester, in the tweet harvester directory, in the harvest directory, in the when the container will use this Docker file, the Docker image, it will create a harvest directory and use it as a working directory. It also uses install some requirements. So pandas, CouchDB, and tweepy. It will pip install them, and then it will just run the tweet harvester. So this is the image that use this Docker file. We use this Docker file to create the Docker image. Then we stop any container that would be harvesting, and we create a new one using the image we just created. and it will run. What will it run? It will run this file. Okay, so what about this Twitter harvester script? So first, what we can see is that so only the 3Pi and the CouchDB models were imported in requirements, and pandas too. What happens that pandas is not necessary, and not any other models, because these other models are already embedded in the when we install Python for the first time. So this script it calls a main function, main method, but we first define a class which is listener, and which is a subclass of 3Pi stream. So why do we need this class? Because, well, first, 3Pi stream, we want to create a listener by just giving it in argument some API keys and a database, so that then it can automatically connect to the API, to Twitter API, and when listening to the stream, to the tweet stream, it can automatically also upload tweets to our database, which is done via the onData method. So, well, we tweak a little bit the ID field because our database is partitioned. So we need this specific partition ... and something else for the CouchDB database to accept a new element. But how does the function get the IP keys? Well, it uses this function, read API keys from this config file, which contains our keys and which is not on GitHub. And so what does it actually do? So first, it connects to the database, the CouchDB database. It reads the API keys, and it also we also declare a filtration list for the tweets, because we don't want any tweets of the tweet stream. Okay, I'll go through there first. So this is a true or while true. So basically, the container will keep running this script until we kill it. We manually kill it. We either manually kill it or either create a new script, a new container using the Ansible playbook. So forever, basically, the script will take one key, check if it's the first time it takes it or not. If it's the first time, it will start listening to the stream and using the filtration above. So this filtration states that we only want tweets that either contain hashtag #auspol and hashtag Melbourne, or either contain hashtag #auspol and hashtag Morrison, or contains hashtag #auspol and hashtag Albo 4 p.m., etc., etc. So these are Australian voting related tweets. Okay, so, and it goes on. It listens to the stream and uploads tweets to the CouchDB database. When an exception is caught, it's either for any kind of error, or it can also be because it has reached the API, the API key, well, the Twitter app linked to this API key has reached its limit, which is the fastest limit to be reached would be 300 tweets per 15 minutes. So when an exception is caught, first we save the time, the exact time when the exception is caught, and we continue. We go to the second key. We do exactly the same thing, and when an exception is caught, we save the time when it's caught, etc., etc. Okay, now let's imagine we have made a loop and we come back to the first key. So for the first key now, it won't be the first iteration. It will be the second one. So here, this will become true, and now we will check if we had enough time between the first time this API, this key, well, this app, the app linked to this key has had an exception, and the time we call it again. So remember, it's 300 tweets per 15 minutes. So we want to check if the delta between those two moments is more than 15 minutes or not. If it's less than 15 minutes, then we wait until we reach 15 minutes. If it's more equal than 15 minutes, then here we go again. So this is the tweet harvester. So once we set up the tweet harvester, the final thing would be the Ansible playbook for the web app. So the first 3 roles are exactly the same as when setting the CouchDB database. It uses its own variable, which are here, and then it calls the setup web app role, which is setup web app, this one, which, just like the Twitter harvester, clones the Git repository, check if Docker is here, and this time it kills any container that has the same name, and we create one by calling a Docker compose file, which is somewhere in the front end directory, this one. So this is it for me. I let one of my teammates present you the front end part and the tweet analysis. Thank you.